Hi, my name is Caitlin Marvin. This is my long video for E63's Big Data class for the final project. For my final project, I selected the Big Data case study for mobile analytics. I picked this topic because mobile applications are becoming an expectation from customers. I wanted to find a solution to collect mobile application data, preferably in a real-time way that was fully customizable. The solution I chose was to use Elasticsearch hosted by AWS and Kibana for visualization. The biggest reason I chose this approach was because it's incredibly scalable, which was a requirement of the project and in analytics in general. Elasticsearch is a powerful search and indexing engine and provides a flexible aggregation on top of the document storage, which is a perfect fit for big data analysis and visualization. It is a full unstructured JSON document storage and provides a query language via a RESTful API to interact with the document indexes or search. Elasticsearch is open source and freely available, and it is constantly evolving. The data is basically real-time. Once it is indexed, it is immediately available. With Kibana, you can have up to a 5-second refresh rate. We can do real-time analytics because Elastic doesn't require some of the processing overhead and lag time that some of the other big data tools introduce, such as Hadoop and MapReduce. It is also incredibly fault tolerant because it provides redundancy across nodes and prevents data loss using optimistic concurrency. Elastic has the ability to detect new and failed nodes, so it can rebalance itself automatically and provide redundancy where necessary. Another cool feature of Elasticsearch is the ability to do a full text search because it's built on top of Apache Lucene, including scoring and fuzzy searches. There are a few cons and drawbacks to Elasticsearch and Kibana. First, it was a bit difficult to set up with a lot of complicated steps, which conveniently I've documented for you in my report, so you can get the benefit of me doing it already. Another con is that this may be a more expensive approach than some other third-party tools. Other mobile application analytics tools such as Flurry or Google Analytics for mobile applications offer free services as long as you do not pass a certain threshold. Elasticsearch and Kibana are more expensive because you have to create your own infrastructure. Since you're creating your own infrastructure, there is some server administration that can be difficult as well. I also found Elasticsearch and Kibana both had a bit of a learning curve at first, especially the Elasticsearch syntax. Other mobile application analytical tools have simpler implementations and setups. Also, Kibana has a policy of no third-party plugins. Kibana has no out-of-the-box reporting either, so you're pretty much starting from scratch on your own. So here is kind of an overview of the steps that I had to do to create try this solution. So first, you have to build a mobile application. Second, create the AWS instances for Elasticsearch and install the Cough plugin. Third, I set up Elasticsearch in the mobile app and sent the data. Fourth, I visualized the data in Kibana. This is an incredibly scalable solution as mentioned before. You can continue to add nodes as you need to. In my current setup, I have 2 nodes and I have 7.15 megabytes of data and over 19,000 documents. I will now go into more detail about all of these steps. Here are 3 screenshots from the mobile application I built using Xcode on my Mac. Xcode can be downloaded on a Mac from the iOS Developer Center. So the concept of my mobile application is select the states that you have visited and then map them on an SVG. Then the customer has the option to share their map on Facebook or modify their map more. While this application is incredibly simple, there were a lot of opportunities to collect data. I decided to send events to Elasticsearch anytime someone selected a state, deselected a state, used the search feature, or if they clicked on the following buttons: map, deselect all, cancel, and share. I also fired events if they clicked on the individual states on the map screen. I captured service timings, application start, application background, application resume, application terminate, and screen views. So you can see kind of the concept. I've checked Alaska, I've checked Arkansas, I've checked Colorado, and I've checked Georgia, left all their states unselected. You'll also see I added in a search feature, so I'm starting to type in Ohio, and it's showing that the only state that matches OH is Ohio. And then you'll see if I click the map button, it then takes me to the map SVG where it has colored the states that I've selected. And then you'll see the little share icon in the top right-hand corner where I can share to Facebook, or I can click choose states and go back and select more states or modify. Also, I built the app in Objective-C. For the Elasticsearch Index, I created 2 medium general purpose AWS instances using the default configuration, each with 3 gigabytes of memory, and I allocated 20 gigabytes of external storage using Ubuntu Linux. Also, while setting it up, I created a new security role to open up TCP, UDP, and ICMP traffic so that the index could be accessed from the internet. Once this was done, I had to set up Elastic on both of the nodes. I used the latest version of Elastic, which is version 1.5.2, and set it as a startup daemon on each of the instances. Then, in order to configure the node across instances so they can talk to each other, I used the Cloud AWS plugin for Elastic and configured the first instance as a master and the second as a slave. This required the setup of a user, public key and secret, to enable read-only access from the discovery between the 2 nodes. I also configured and set up the external SSD drives to the storage path for each of these indexes. Next, I also installed Cough plugin to the first instance so I could monitor the health of the index. I also downloaded the latest version of Kibana and installed it behind a reverse proxy using Nginx. When this was said and done, my Elasticsearch instance was ready to go. Then, the only thing left is to implement the service calls to record the event from the mobile application. To do this, I took advantage of Elastic's RESTful service to access the index. In order to help, I used a couple of libraries to ease the interaction between the service and the interaction with the application events. The first is called AF Networking, which is a networking abstraction layer to provide the capability of calling services easily. The second is called Mantle, which allows common model classes to be serialized to JSON from the application events that I wanted to record. The events collected from the app also record device-specific information and the state of the application when the event was recorded. Along with it, every device is tagged with a unique user ID that does not change in order to tell the unique user. Just to clarify, this isn't the Apple identifier. I generated my own token. Then I tag every instance of what I wanted to record throughout the application, which subsequently made a post request to the Elasticsearch Index /analytics/events resource with the serialized event and index the event within Elastic. The analytics then can be automatically viewed and searched in the Elastic Index in Kibana. Kibana is an amazing visualization and query tool built off the Elasticsearch Index. It provides the capability to do several visualizations while allowing a full index search across all instances in real time. Elastic has its own DSL for querying the Elastic Index. For example, if I wanted to find all the states that were selected from iOS 8.2, I would use deviceinfo.operating-system-version:8.2, as you can see here. This returns all the states that were selected and deselected on iOS 8.2 devices. So you see below it's highlighting where it's matching it. These queries can also be used in the visualizations themselves, which provide even more flexibility over the breadth of data you can gather. I created a dashboard with 4 visualizations, just to give a quick example. The first was events by user, which is represented as a histogram by timestamp in 30-second intervals. So you'll see here, I'm looking at the last 15 minutes, and in the last 15 minutes, I have 2 unique users as represented by their unique device identifier that I generated. And then this is timestamp per 30 seconds. So you'll see the events generated by different ones. So for example, in this interval, only the blue dot interacted, but in the previous one, the green one was more active in that 30-second interval. Now, in this chart, it's a pie chart showing the most frequently selected states in the inner circle. And on the outer circle, it shows whether it was selected or deselected, which is represented in a true, false, and then the most populous states are reflected in the inner pie chart. The third, which is right here, is service timings in milliseconds with 300 millisecond bucket ranges. The fourth was the most common events represented in a line plot. Now I will show a quick live demo so you can see how the events are indexed in real time. So here is my Kibana window, and I'm going to come in. Here's the dashboard that we were just looking at. So currently I'm looking at this year. So you can kind of see the different devices. I ran around work convincing people to let me install my app on their phone and ask them to generate data for me. But I'm going to come in so we can find ours. So I'm going to say the last 15 minutes, and then I'm going to change my refresh interval to 5 seconds. So now I'm going to put this back. And so you'll see I'm now going to generate for you. So I have my simulator running, and I'm now just going to click on Alaska and just keep toggling it back and forth. And you'll start to see it come in. Alaska, false. False, so Alaska, true, and then Alaska, false. So you can see I'm selecting and unselecting it. And then I'm going to remove my filter. And then I'm going to select other states. Very fascinating. So you can see how my chart changes. And now do one more and I'll map. So then you'll see this option come through. And you'll notice down below, I have a page view, so my screen view, state selected, I clicked a button, as well as mapping back the service timings for this data back and forth. And then I can click some other states and go back. And I can deselect all. And you can see it's constantly updating, which is pretty cool. And here you can see the data coming through at 9:41 p.m. Alrighty, well thanks so much for listening to my presentation.